This is the tutorial video for design patterns. I'm going to introduce 5 of the most popular design patterns: factory, strategy, adapter, observer, and decorator, with an example for each one. To see what are these patterns and how we can deploy them in a very basic way, I used PHP for the coding part. For non-PHP guys, if you're familiar with Java, C#, JavaScript, or any high-level programming language, PHP is clear enough for you guys to understand the examples. And design patterns do not actually depend on your programming language. However, it's required to be familiar with OOP. The list of the top 5 popular design patterns may be a bit different for other programming languages. However, these are the top 5 patterns for PHP. I tried to make examples simple as possible by avoiding algorithms, dependency injection, or exception handling, this kind of stuff, just to focus on the title. If you heard about design patterns but didn't try, this video will be good for you. Alright, what are design patterns? In software engineering, a software design pattern is a general, reusable solution to a commonly occurring problem within a given context in software design. I released a video some while ago for design patterns, what are design patterns, their benefits, and why developers should use them. I'll put the link on the top of the screen, so if you didn't watch that video yet, make sure to watch it first. The first pattern is the factory method. The factory method pattern is a creational pattern that uses factory method to deal with the problem of creating objects without having to specify the exact class of the object that will be created. This pattern is the most popular design pattern for PHP. There are several ways to implement factory. We have factory method and abstract factory as 2 patterns. However, we have simple factory and static factory method too. I'm going to cover the factory method. It's more often. For implementation, we have a method with some input parameters, and it creates or builds the object based on the parameters. With the factory method, we don't have to memorize the initiation of each class to create or to build them. So let's try with the factory method. This is the well-known car example. I have an interface with 2 classes as cars. It's possible to have 10s instead of just 2. Then you need to memorize the initiation way of each one. Also, if you had to make change to the initiation, you need to fix the occurred points in the whole of your project for it. This is a problem, so I can solve this commonly occurring problem with the factory method. To do that, we need to have an interface to provide the creator method. Then we can use it for our factory or factories. Car factory, make car, color. 2 parameters are enough in case. This is the creator method. Now it's time to have a class as the factory. Let's name it main car factory. Car factory. Make car. Car type. Color. Do I have them both in the interface? I'm gonna use a switch to create the object. For sedan, a new sedan. For color, and for plate number, I prefer to put the car type as the default plate number. It's a good idea to use the factory method to build objects, not just to create them, same as I did. For SUV, same things. It may look weird to you why I made the SUV the default case. So I built the cars inside of the switch because the build for each one could be different. For sedan, for example, it may just one color be possible to build. Or may our factory has no plan to put plate number on sedans or a hyphen. Building can be more complex and the factory method can handle it. Okay, it's time to make some cars. Let's have the main car factory. Main car factory. I'm asking for a sedan car, a blue one. Let's dump it to see the result. And an SUV, red. Let's run it. Sedan, blue, SUV, red. It's done. This is not the best way we can deploy the factory method. I could use an abstract class too. With the factory method pattern, now the main factory class is responsible for creating cars. Then for future changes, we just need to update the factory class. It's very useful and easy to learn. In some situations, you may have different ways to solve a problem. You may be able to use different patterns, not to do exactly the same thing, but to solve the problem in another way, for this example or for other examples in this video. But this is just an example to describe how this pattern works. The second pattern is the strategy. It's a behavioral pattern that enables selecting an algorithm at runtime. Instead of implementing a single algorithm directly, code receives runtime instructions as to which in a family of algorithms to use. Deferring the decision about which algorithm to use at the runtime allows the calling code to be more flexible and reusable. So what does it mean? This strategy is about having different implementations to accomplish the same thing. With this strategy, the client can choose the needed algorithm without knowing the actual implementation. It helps to implement algorithms without engaging with details. For the coding part, let's have the cars. I have an interface with some classes, person, and 3 cars. I need to deliver a person as a passenger via a car, and I need to decide between cars. So the problem is, each time going to transfer someone, you need to make some decisions between cars. It could depend on your person, destination, or cars, or maybe you need to do some paperwork before you be able to use a car. So different cars we have and different ways to do it, which means different algorithms. It's possible to have an airplane, a ship, or a chopper as your vehicle rather than just cars. Then for the airplane, for example, you need to arrive passenger to an airport first via a car, then deliver lucky passenger via an airplane. Also, in that situation, you may need to consider the airspace of some regions, for example, the Russian airspace, due to the sanctions and that fucking war. So without this strategy, each time for this scenario, you have to put all of your codes so you repeat yourself in code every time. And whenever you need to change your algorithm or algorithms, you have to change it in the whole of the project. With this strategy, this is no longer a problem. A more complex example makes the problem more sensible, but I'm going to keep it simple. So if you have a different idea about the example or other examples, make sure to drop a comment, let me know what you think. For this example, I have 3 cars. I can pick one of them, maybe based on the travel distance in case. So let's first declare a class for this strategy. I need to have the distance, then I can decide to pick which car to use. Now, if travel distance be lower than 200 miles, it's better to use Tesla. It's handier. Also, for long distance, you may get out of charge. For distance under 300 miles, I think Bugatti is better because it's faster. And for longer distances, BMW, which is more comfortable. Now, I need a method to get the transfer method from the car. Person, just the call is enough. However, it can be complicated in a different case. So let's use this strategy. $200 in a person, John, for example, with a new passenger, Sophia, this time. So it chooses the algorithm in the runtime. It's fine. John via Bugatti, BMW for Sophia. For the use case, payment method, navigation, sorting, and storing data are some of the real-world use cases you can consider. Let's go to the third design pattern. The adapter pattern is a software design pattern that allows the interface of an existing class to be used as another interface. It means the adapter helps objects with incompatible interfaces to collaborate. Let's go with an example of the adapter. Another cars example. I have two interfaces for my cars, one for electric car and one for fuel car. You can see these classes which are implemented of the interfaces are incompatible. And the problem is incompatibility, but I'm going to make them collaborate via the adapter pattern. First, let's see what we have here. For electric car, plug power cable, unplug, and recharge. Charging process is simple. Just plugging the cable in will be enough to call the recharge. For fuel car, put nozzle, remove nozzle, same as electric car. Pull lever, I assumed the pull lever be a toggling case and refuel. So I have one more method and one more condition to check for the refuel. Also, I have a function to format the output. Let's split the view. Now I have this file on both sides. I'm gonna execute it to see if it's working or not. New Tesla, plug, power cable, and recharge. For BMW, we need to put the nozzle first, then pull lever, and finally refuel. Initiated to recharging, recharged, initiated to refueling, refueled. Okay, it's working. Now both not working anymore, and that's alright. Let's comment them. So my goal here is to have the BMW, which is a fuel car, to collaborate as an electric car, to refuel the BMW by recharging it. It may look ridiculous, however it's not, it's more funny, you'll get that. fuel car to electric car, electric car as my goal. For the adapter, we need to have the target object inside to make it collaborate. Fuel car. For the implementation, plug power cable. First, put the nozzle, then pull the lever. That's it. For unplug power cable, pull the lever again. It's a toggle. Then just remove the nozzle. And for recharging, just the refuel. Now let's try with the adapter. Plug the power cable, recharge. That's it. My fuel car refueling just like charging an electric car. Or in other words, we just recharging a fuel car. It's not possible in the real world, but here in programming, the story is different. You can stop the bullets here or jump from one roof to another. And to do that, simply you just need an adapter to make a collaboration between a human and a bird. You will implement your adapter with human interface and accept an object of a bird type in your construct. Then your human can fly if you call the walking or jumping. We have done with the adapter. Let's go to the fourth one, the observer. It is a software design pattern in which an object named the subject maintains a list of its dependents called observers and notifies them automatically of any state change, usually by calling one of their methods. It is often used for implementing distributed event handling systems in event-driven software. The observer is a behavioral pattern. It will observe state changes that happen in the observable, which is called subject. An observer pattern is a good solution to handle a one-to-many relationship between objects. Instead of injecting anything without a plan or doing it by polling, which is not an accurate solution considering response time, and also pulling for small intervals gonna kill the hardware resources. Just do it by observer pattern and your code will be good in use and read. In example, I have a Tesla car and I need to wash the engine in the announcer. To do that via polling, I need to check the status of the engine frequently inside the announcer, which has performance and accuracy issues. And coding would be a hard thing. Observer solves these problems. To deploy it, we need to have two interfaces, subject and observer. Instead, for PHP, you can use SPL subject and SPL observer. Both are available as built-in interfaces for the observer pattern in SPL. However, I prefer to have mine. For subject, the observer pattern is a kind of a one-to-many relation. So we need to be able to add many, at least one observer. So let's have attach to attach the observer or observers, detach, and notify changes. For the observer, update to get called from the subject, which is the SPL subject, and SPL observer. It is not necessary to define your interfaces exactly as mine, which are the SPL interfaces. You can have your own as you need. For example, if I have something like a status code here or input data in Observer, it can be helpful, or multiple notifiers for the subject can be useful too. However, I'm going to keep them like SPL. We have Tesla car as the subject. It's the observable class or the target class. Let's have the attach. To have it, we need an array to contain the observers. Also, we should be able to remove any of them as need. And finally, for all, update them. So for the observer, the engine status, for example, we need to notify observers after their status has been changed. That's it. Now let's define our observer. As an observer, our car may have an announcer. It's useless, however said it's usual. We have just one method to implement. EOL for a new line. This looks enough. Now let's say maybe, just maybe, our Tesla car has an SMS notifier as the security system. Or maybe it has a satellite communicator. I prefer satellite notifier. Add. Let's have the class name too to have a more clear output. new Tesla car, attach, announcer, satellite notifier, toggle the engine. It's done. Okay, what about detaching the announcer? One more toggle, detach. Announcer engine on, satellite engine on, satellite off because of the second toggle. And yeah, we finished with the observer. Let's go to the last one, Decorator. The Decorator pattern allows behavior to be added to an individual object dynamically without affecting the behavior of other objects from the same class. Decorator use can be more efficient than subclassing because an object's behavior can be augmented without defining an entirely new object. It's known as the wrapper and it comes under structural patterns. Subclassing is static and applies to an entire class, but the decorator will add to individual objects at runtime. In another hand, also, almost all programming languages, included PHP, followed single inheritance. This pattern is an alternative for subclassing. We can easily add a new behavior without changing the existing class. And we can keep decorating until we get satisfied with the added behaviors. In real life, this is common in product manufacturing. Companies produce the very first product, then they decorate it with a new shape, some change on behaviors as new features, and make some improvements. Let's have the example. I have an interface with two methods and the Tesla Model 3. The purpose is to make a couple of new models, such as Model Y, based on the first model. To do that, we can use subclassing, but inheritance is static and subclassing limited to one parent. Then what if we just decorate the base model, which is the Tesla Model 3, as a new model? To deploy it via codes, need to satisfy an interface as the wrapper and accept an object as the wrapper. That also satisfies the same interface or a class with that interface. These numbers you see I noted to remember for each model. So for Tesla Model Y, let's have the Tesla Model 3. I could use Tesla car instead, but if we do so, it makes it possible to accept any object implemented from the Tesla car, and it causes some issues. For example, you can't accept Model Y to decorate the same model. For get range, it's 58. And for get seats, two more seats. I have decorated the Model Y from the Model 3, just like in real life. You can put more seats or more batteries on the base model to provide a longer range. Okay, let's have Tesla Model S. Same as before. Tesla Model Y. Get range. The rapid is Model Y, so it should be 75. Four seats. Just 3 more extra seats. Okay, let's to have our model. Model Y. New Model 3. Get range. Get seats. For Model S, Model Y. Done. Now we have Model S and Model Y from Model 3. So what about using a base class as the rapid, not Model 3? For example, Tesla Model Basic. We need Model 3, gonna accept Model Basic. Let's duplicate this. All of them Model Basic. Let's put Model Basic. It's fine. Or even I could use an abstract class instead of implementing from the interface, which can be better. Okay, we have done with the Decorator pattern too. As the final word, you can do what you like in your code. However, the way you structure codes is important. The way how you solve problems, in case common problems with common solutions can impact the result. A good code should be reusable, maintainable, and extensible, and design patterns can be very helpful in achieving these goals. It does not matter which language you are programming with, practicing design patterns will make you a better developer and makes the job easier. This is all I have for the top 5 most popular design patterns. There are 23 design patterns and I talked about 5 of them in this video. So, if you found this video interesting, give it a like. If you like to get my next videos, make sure to subscribe and press the bell. For questions, just drop a comment below and I'll do my best to answer that question. Thank you for watching. See you in the next video.